Chapter 17 review. Looking at number 2, it says if a charge is displaced in a uniform electric field perpendicular to the field. So that's saying the charge is displaced this direction. That actually, how is that equal to the potential energy? It's actually zero. You're not getting any change in potential energy because you're going with, it doesn't take any exertion to do that, I guess is a way to put it. If you go with the field or you go against the field, there's energy stored or used. So it's going to be like option B there. I believe number 3 is also on our list here. And number 3 is differentiate between electrical potential energy and electrical potential. Let me read to you the way the book says it here. Let me just get back to the questions here. Okay. Number 3, electrical potential is the electrical potential energy associated with the charge divided by the magnitude of the charge. Electrical potential is a characteristic of a point in space that is independent of charge at that point. Another way you can look at it is electrical potential energy is the energy associated with the charge. Electrical potential is that energy divided by the charge itself. Number 8. The magnitude of a uniform electric field between two plates is 1.7 times 10 to the 6th newtons per coulomb. That's your electric field, E. If the distance is 0.015 meters, find the potential difference. So potential difference being voltage, you're finding the voltage. And your equation will be, where's my mouse here? V equals ED. You're given electric field, you're given distance. Number 9, you have that rectangle, and with that rectangle, they want you to find the electrical potential at point P when you got charge, and charge. So you're going to use the equation V equals, and I'm sorry, I'm running with my mouse from the desk here, Coulomb's constant times charge over D. So you've got charge and D, charge and D, charge and D, and you're just going to find those three. I'm sorry, I wrote the wrong thing there. Voltages. Number 10. What happens to the charge on a plate if you hook it up to a larger potential difference? With a parallel plate capacitor, you've got plate, battery. Oops, my drawings are, I'm sorry about the drawing. Battery. If you double the voltage, you will double the charges because capacitance, where C equals Q charge, capacitance equals charge over voltage. If you double the voltage, capacitance stays the same. Q has to double as well. Okay. Number 12. Why is Earth considered a ground? Earth is enormous, so it has a lot of extra electrons to give or take whatever it needs to do there. If ever you ground using the Earth, you will reach a zero in terms of equilibrium. However, two other items, to address the second part of the question, two other items can ground each other. You will reach equilibrium between the two charges. It may not be zero, but you will reach equilibrium. For, let's say, one has a charge of 10, one has a charge of 20, and if you grounded them together, they'll neutralize and have a mutual, each one will have a charge of 15 if you grounded two things together like that. Number 18. A 12-volt battery is connected to 6 picofarads, pico being times 10 to the negative 12th capacitor. What is the charge? So we got 6 picofarads, we'll go here. 12 volts, we'll go there. Find charge. Okay, you can solve that. Number 20. You know what? Let's end this recording right there. 1, 2 through 18.